Okay, this is the sixth video in the Reasoning and Proofs series. This is the second half of postulates, properties, and proofs. We're going to talk about proofs. In the last video, we just saw these postulates, which were the fundamental building blocks of our geometry understandings, and these algebraic properties that are always true. These are the laws that govern our logic with algebra, and especially symmetric, transitive, and substitution property will help us understand geometry, because those things also work in geometry. Plus we can take these facts about the measurements and replace them with numbers, and we can also talk about how we can add together different line segments and different angles if we use our notation correctly. Right, with all that information, we can start constructing proofs. The most standard way of doing proofs in geometry is with a two-column proof. I'm going to use this very basic algebraic question here to show us how to do that. So first of all, we put the statements that are true on the left-hand side, and on the right-hand side we give a reason or justification. So I'm going to say that 2x plus 3 equals 5, and that's what we've been given. So we always start with what we've been given. Then I hope you all know that what we need to do is get rid of this 3. We want to end up with x equals 1 down the bottom here. So we need to get rid of this 3. So subtract 3 from both sides. That's called the subtraction property of equality. Then we're going to simplify all this. So, for example, 5 minus 3, we can replace that with a 2. And this left-hand side we can replace with 2x. So that's called substitution of equality. Substitution property of equality. So we're taking something complicated, replacing it with something simple. Substitution. Now you can see we need to get rid of this 2, so we divide both sides. That's the division property. As long as you do the same thing to both sides, it will remain equal. Division property of equality. And now we can simplify, so we take the 2 on 2 and replace it with the more simple version 1. That's called substitution property. Okay, a little bit later I'm going to, instead of doing 2 steps here, we're going to do 1 step. So we're going to not include the substitution property, but it's good to do it at the start to get to think about what it actually means we're doing. Here's something about converting from Celsius to Fahrenheit. So if you've got the Celsius to Fahrenheit, can we change it to Fahrenheit from Celsius? So here we go. We start with what we're given. We need to get rid of this, so we use the multiplication property of inequality. We simplify that, so that's substitution property. And we need to add 32 to both sides, so that's the addition property. And then we simplify that. But now we've got the f on the wrong side, so something equals f. We change that to f equals something. That's called the symmetric property. And we're where we need to be. Okay, so that was 2 sort of algebraic proofs. Let's do something geometrical now. So here we want to show that if AB is congruent to CD, then x equals 7. Alright, so we're going to start with what we're given, and we're going to end with x equals 7. So we're going to start with AB is congruent to CD. And we're going to define what that means. That means the length of AB is the length of CD. Right? We want to get away from congruent to an equals, because then once we have equals, we can do some substitution of algebraic terms and numbers and make it much easier. Alright, now we want to get rid of this minus 6 here, so we use the addition property and the substitution property in simplifying it. And then to get rid of the 4, we divide by 4, so division property. And once we've divided, we simplify, so substitution property. You don't need to write substitution property for these. I'm just telling you. Right, next one. Alright, here we've got CG is congruent to EG, and GD is congruent to GF. So then we have to show that CD is congruent to EF. Alright, so we start with what we're given. We always write down what we're given. Okay, we've got congruent. To make it easier, we'll change to equals. So that means length of CG equals length of EG, length of GD equals length of GF. That's our definition of congruence. Then we'll use our segment addition postulate on this segment here. CG plus GD equals CD. But now, because we got a CG as EG and GD as GF, we'll replace them using this substitution. Okay? Now let's turn our attention to this one. So EG plus GF is EF. That's segment addition. And then we notice, hey, EG plus GF, EG plus GF, it's the same thing. So CD must be equal to EF. That's substitution property. We're not quite back at our required answer yet. We said the lengths of these two line segments are the same. Oh, okay, what's that mean? That means they're congruent. Lengths of line segments are the same, means their line segments are congruent. Okay, one last example. So if angles 1 and 3 are complementary and angles 2 and 3 are complementary, does that mean that 1 and 2 are congruent? Well, let's work it out. So we're given that 1 and 3 and 2 and 3 are complementary. Let's define that in equation terms. So measure of angle 1 plus measure of angle 3 equals 90, and measure of angle 2 and measure of angle 3 equals 90. So if these two things both equal 90, then by substitution or by transitive, we know that they're the same. I'd probably prefer to use transitive there, but substitution is correct as well. We know by reflexive property that this measure of 3 and this measure of 3 are the same. Even though they come from different statements up here, they're the same. So that means we can take both away from each side, take measure of 3 from both sides, and be left with measure of 1 equals measure of 2. So if the measures of two angles are the same, that means they're congruent. So we have proven that. Okay. For my students, I will give them these definitions and allow them to use open book to do this. But they should be able to give a reason for each step that they've done here and to make it clear. All right. Go practice.